theoretical and experimental probability. If you want to write your own definitions for these vocab, you can. Probability would be how likely something would occur. Outcome is the probability of an event. The sample space is the total set of all outcomes. An event would be an outcome or set of outcomes. When we're talking about probability, we can either have it as a fraction, decimal, or percent. If I had 100%, as a decimal, that would just be 1. And as a fraction, that'd be 1 over 1. So there's 3 different ways that we can represent probability. Theoretical probability. We always label probability with a P and then whatever we're talking about. That stands for the probability of an event. When we're talking about theoretical probability, the total always goes on bottom. The total number of outcomes always goes on bottom. And the possibilities, number of possibilities goes on top. If I had the question, a C-Day has 5 upbeat dance songs and 7 slow ballads, what is the probability that a random song selected is an upbeat song? You should always find your total first. I have 5 upbeat songs and 7 slow songs. So my total is 12. Total always goes on the bottom of your fraction. It's asking for upbeat songs. I have 5 total upbeat songs, so that'd be at 5 over 12. If I'm looking for this as a decimal, I just do 5 divided by 12, and I get 0.1 or 0.417, which would be the same thing as 41.7%. If I roll two dice, or 2 die, a red and a blue, what is the probability that the sum is 6? Well, if I'm finding my total right away, I have this picture to help visualize it. There's 36 different outcomes because there's 6 possibilities for the red die and there's 6 possibilities for the blue die. So 36 is my total. I want to find out that the sum is going to be equal to 6. So if I look at my possibilities, I have 1, 2, 3, 4, 5 different possibilities that the sum would be equal to 30 or to 6. So that'd be 5 out of 36, which would be the same thing as 0.139 or 13.9%. Now I want to find out the difference is 36, or difference is 6. 36 goes on the bottom of my fraction. And when I talk about difference, it means subtracting the 2 numbers. The only way that I could get 6, since my highest number on a die is 6, would be 6 minus 0. There's no combination over here that has 6 minus 0. So there is a 0 possibilities that I can get the difference is 6, which would be the same thing. It's 0% or just 0. The right cube is greater. Well, I'm still going to have 36 different possibilities. And I'm going to circle all the places where the red cube is going to be greater. So there's 15 possibilities where the red cube is greater. That's the same thing as 5 over 12. So theoretical probability is if I know the total different outcomes, what's the probability already given? When I'm talking about a complement means the probability something didn't happen. Whenever we're talking about the probability something didn't happen, we can always do 1 minus the probability it did happen. 1 because that's the same thing as 100%. So the game Battleship has 5 different ships. There's 17 holes in those ships with a 100-point grid. I want to find out what's the probability that the first shot misses all targets. So I'm looking for the probability that it misses. Well, I can also do 1 minus the probability that it will hit a ship. And if I have 17 different holes that it can hit at, it would be 17 over 100. 100 because there's a total of 100 different holes on the grid, and 17 of those holes would be hitting. So I'm going to rewrite 1 as 100 over 100 because I have to have common denominators. And that would be 83 over 100, or 83%. Each student received a 4-digit code to use on library computers with no digit repeat. Esther received the code 7654. What was the probability that he would receive a code with consecutive numbers? While I'm dealing with this, I first want to think out my total. And here I have 10 different numbers that I can choose from. Does the order matter here, yes or no? Yes, it does, because 7654 would be different than 6754. So my total is going to be a permutation. There's 10 different numbers I can choose from, and I'm choosing 4 of them. So right now I'm just looking for my total number. So that would be the same thing as 10 factorial over so my total number would be 10 times 9 times 8 times 7, which is 5,040. So I'm going to write that on the bottom right away because that's my total number of outcomes of codes. Now consecutive numbers, I'm going to write out all the possible consecutive numbers. I can have 0, 1, 2, 3, 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7. So here I have 7 different outcomes. Now, 0, 1, 2, 3 will be different than 3, 2, 1, 0. So I'm going to multiply, there's 7 different outcomes here, times 2. Because I can either write these numbers from smallest to greatest or greatest to smallest, and they're still going to be consecutive. That means I have 14 different options, which is the same thing as 1 over 360. DJ randomly selects 2 of 8 ads to play before her show. 2 of the ads are by a local retailer. What's the probability that she will play both of her ads before her show? Is this permutation, combination? This would be combination, because it doesn't matter which ad plays first. So I have a total of 8 different ads, and I'm choosing 2 of them. Again, I'm looking for what number is going to be going on the bottom of the fraction, my total. So this would be 8 factorial over 8 times 7 over 2 times 1. I can reduce, so it'd be just 4 times 7, which is 28. So 28 goes on the bottom of my fraction. Total always on bottom. Only 2 ads are plain, and only 2 of the ads are from the local retailer. So there's only one option here that she can play both of her ads. So it would be 1 out of 28. Those are theoretical probabilities. When I'm talking about experimental probability, that's the number of times an event occurs over the number of trials. When you're talking about experimental, there's usually going to be some sort of grid or table shown because experimental is different than theoretical. So if I want to find the experimental probability of choosing a diamond, I'm looking at this chart given here. It's always easiest to find your total right away. So right away, I'm going to add up my bottom numbers, and I get 26 as my total if I add these all up. The experimental probability of choosing a diamond. There's 9 diamonds, and there's 26 total. So the experimental probability of choosing a diamond would be 9 out of 26. Find the experimental probability of choosing a card that is not a club. Well, that's going to be the same thing as 1 minus the probability that it is a club. Probability that would be a club would be 7 out of 26. And I'm going to write 1 so they have common denominators. So this would be 19 out of 26. If you wanted to, you could have also added 5 plus 5 plus 9. Find the experimental probability of choosing a red card. That's going to be hearts and diamonds. So I'll have 5 out of 26 for the hearts and 9 out of 26 for my diamonds, which would give me 14 out of 26. And you should always reduce your fraction when possible. What's the experimental probability of choosing a card that's a jack? Nowhere on this chart is it talking about jacks. So we need more info. We could find a theoretical probability of choosing a jack, but since it states experimental, we would have to have more info here. Homework page 806, 1 through 20.